yourself.
Okay, so I am Peterson. I'm a researcher at the Center for Integrated Facility Engineering. Professor Fisher is my advisor and sometimes my babysitter, and make sure that I stay on track where I'm following my research question and not just out fishing.
And one unrelated fact that's going to be surprising that you would not otherwise know.
I was a laborer for 10 years and graduated in the very bottom of my class. My friend Matt Zebarth was seated to the left of me, and my name is Peterson, and I realized we were all seated out of order because they didn't think we would finish high school. All right, thanks, but it worked out okay.
I present to you, Forrest.
Thank you. And should we introduce Chris?
And Chris is speaking to you.
We're co-presenting.
All right, Chris, tell us a little bit about yourself.
So I'm Christopher Fugate. I'm a civil engineer here in California. I'm an Autodesk expert elite person. So that just means that I spent way too much time in the forums, and Autodesk has decided to recognize me for that fact. I don't know if that's a good thing or a bad thing, but I guess it's all right. I'm a blogger as well, so I blog on Civil 3D, all things Civil 3D. I've been kind of busy, so I've kind of dropped that off. But that's how Forrest found me. Through my blog, and I blog sometimes about subassembly composer, and I helped him do that portion of it.
And can you think of one ridiculous blog comment that you got? Just read it through.
Anyone interested in buying some diet pills?
All right, thanks. Okay, so today we're going to talk about what we've been calling the construction information management, the acronym,
No.
VDC SIM.
I think it's civil infrastructure.
Civil information management.
But that one sounded pretty good.
Civil integrated.
Civil integrated
It varies, but FHA calls it civil integrated management.
Civil integrated management. I call it civil VDC.
I like Tim. Timmy.
Timmy.
Transportation.
Transportation.
So out of Monty Python, right?
I think it's South Park, but I'm not sure.
So the question that we're focusing on for this presentation is, why must we elaborate the detail in the information model to represent the field operations? And so elaboration in this case is a technical term, and that's basically the key word here. And so the short answer is the 3D model represents the details for dimensioning. And so from that point, when you go to the construction level, you need to elaborate the model to represent your applied resources, which is usually labor, your equipment, your material, your haul. And so this allows you to dispatch and do your progress monitoring in small chunks. Otherwise, we would just have one line item said project, and I'd say, I'm 83% complete. And you say, how do you know? I'd be like, that's just where we are. So we break it into small pieces and aggregate it up so we can come to a very exact point of where are we in the project and what do we need to do to finish. Without that, that method of elaborating the project detail, I read a book written by, I presume he was a civil engineer, named Vitruvi, who was a Roman engineer and built lots of great things, siege engines. But in his book, he also had a chapter on project management, and I was amazed that from the project management method he was describing was no different than the project management method I was also taught to use. So elaboration is, I guess, a big step forward if you can apply it within the civil information modeling system. So our big idea is in 2010, we wanted to find a contractor who would allow us to embed ourselves with them. The big fancy word for it is we call it an ethnography. We went to live with the natives until we learned to eat their food, and they forgot that we were somebody else, and then they just started letting us see everything how they did it. So we found a contractor, vertically integrated contractor, meaning so we don't have to deal with subcontractors. It's an all-in-one operation. They own everything from maybe the batch plant all the way down to, they don't own the laborers, but basically they have the same guys working there for 20 years. And every project, it's the same chunk that goes everywhere. And we're looking for these hard bid. Hard bid projects was important because we wanted to have an environment where the contractor was forced to eat their mistakes. And it makes them care a little bit more. We didn't want to be in an environment where something goes wrong and you simply negotiate your way out of it and ask for more money. You know, we all know in highway construction it's not quite so rigid as hard as it seems, but still it's much different than, say, the building industry, where they can basically throw everything to the wind, build something without a schedule, and as things go wrong, well, you know, things just didn't work out. And the last thing is just to keep this in perspective, is we observed one project, so everything I'm showing you is just for this company in Caltrans District 10, in Merced. You know, I can't say this applies to anything else in the world. So there's my little disclaimer, but I'm pretty sure it does apply to everything else. So what we're going to talk about is, first I'm going to go through the what we call the VDC theory, just a refresher, just so everybody knows maybe the terms I use and how I think of VDC. Seems like a lot of people have different ways of thinking about this. Then we're going to go through, we call it action research, where we partnered up with a company, and then they became kind of our guide dog once we got out of the academic world and got into the real world. You know, we'd be a little clumsy and confused as to what's going on, so they kind of showed us around. We had the host project. We'll talk about the VDC pit, a little bit about level detail, which is elaboration, then the integrated model, and then some suggestions of what we saw if we had some of this continued work. When we started this, we think things would have been much easier. So, some background. So this is how I see the integrated model. It's basically a Venn diagram with the old project management triangle. You know, it's scope, time, cost. So when it becomes integrated scope, time, cost, it started making a little sense to me, because, you know, scope is quantity takeoff or bill of materials, time is the schedule, cost is the estimate. And I looked at, you know, we put in here, well, what is this in a pure sense? Like, if I just showed up to the project with time and I did no project scope and we had no cost, what is that? Well, that's MOB. Everybody loves mobilization. It's free money. So scope, you know, we have permanent, modified, temporary, and removed objects. Pretty much sums up all the categories on a project. And cost is, time is a milestone. Sorry, I got that backwards. Is milestones. Cost is MOB with no time and scope. That was backwards. And so where these cross over, you have scope, time, production. Well, that becomes a 4D model simulation. And when you have scope, cost, well, that's unit cost. That's your, labor per hour. And time variable cost is usually like rental equipment, haul trucks or cranes and things like that. And where these all merge in the middle is the activity. And so that's the activity that becomes a bit of a technical term, because that's when we say activity, we're talking about the scope, time, cost, and all the different aspects that relate to this core component. Now, of course, I ignored quality, because as my colleagues tell me, we don't design things to be crap. We design things to be good. And I said, well, we don't build things with that idea, but of course we should. So this was all laid out by Darwich, who is now a professor at UCLA, the computer science department. He's been there since presumably about 1990. And this was proposed as part of a research proposal in the first year that Sci-Fi was around. And so this is basically as old as everything. So the contractors have to have a way of representing these items, and over the years, no one can tell me quite where these came from. These coding systems have developed. One said, well, we had a code for 10, 20, 30, 40, and then that's what we used for our corporate accounting, for our reporting to the, to the IRS or whatever, and the guys in the field tacked on some more levels. And he said over the years, it just got longer and longer. So these codes here, and to help everyone in the overhead here who's not actually on the project understand what they're looking at, it's just been something that's evolved. And so if I look over here and it says, if I just tell you we have 8 hours, you go 8 hours of what? And in this case here, you back up and that CO1 tells me, well, that's a carpenter journeyman. If it goes CO2, it would have been a carpenter apprentice. So I know that this carpenter up here, he's CO1, And so if I wasn't there and I didn't see this picture, and I just showed you that code, you're supposed to imagine all this happening. You can just see it. And if I show you this without the code, well, you should be thinking the code. So this is how we tie these things together. And so in preparation of going out on the project, we tested this for several years with a large number of master students in I think 3 or 4 different classes. We wanted to see if this integration system worked. Of course, we were using the building system because it's a little bit further ahead. And so here's 5 different projects we gave students. Some of these classes were 5 months. And the students took the model, took out the quantities, passed the quantities to the schedule. We used something a little more advanced than Primavera, but sometimes use Primavera. And that's a location-based schedule. I put out all these upon it, wrote a book and did a lot of work and kind of popularized, I think in the United States, the line of balance schedule. So the line of balance schedule has all these funny wiggly lines, but it's basically like a production chart. You imagine the bottom is time, and on the vertical axis, that's location. So as you're moving through the locations of the project, you're running through time, and you can see the production rates, because if you're moving through the locations faster, well, the slope of your curve will be steeper. So we then use middleware. There's lots of different types of middleware. This one was a company from Finland, built this really nice middleware package, and that allowed us to move our quantities into this VICO and out and into, say, like either a spreadsheet or some other type of more advanced scheduling software. I mean, not scheduling, estimating. In this case, we have Sage. I mean, it could have been MC squared or something. And then from there, the students say, hey, that's not the cost we want. You know, some of these were integrated teams with an architect, the architect, and the cost manager. They say, okay, well, we need to change this project to have lower costs, and everything. So all this worked fine. We published papers on it, and we were completely confident we are ready to take this out into a heavy construction project, and we're so confident we'll go to a project and actually implement this. So we looked for a partner. Oops, really? So out in the construction project, the standard is once you have a baseline schedule, of course, in the first week of the project, the schedule is no longer any good. So you have a replanning method. In the building industry, sometimes they try to have one schedule and they hold everyone to it throughout it. But in the heavy industry, I've noticed we usually just make a new schedule every month or every week, whatever's needed. So you have your scope that you're building, you have your production, your schedule, your field crews. So you go through, you analyze, create your production, have your plan, you direct the field crews, go do this, they do it, you measure what they did, you update your bill of materials, what's been completed. From that, you can then figure out your production rates. Presumably, you know, no one does this, you then reforecast your schedule and redirect the field crews, and you complete the cycle. Okay, so here's our action research partner. This is RGW Construction. They're not particularly, they don't understand what SIM is or any kind of modeling. I mean, they're the kind of guys, they get their paper-based plans in PDF. They take ag tech, they review it in ag tech, and they create and heavy bid their estimate, and that's just what they do. But they've been participating in research for quite a few years with Professor Tatum. Professor Tatum has published numerous papers on this company saying, this is an innovative organization. If you want to try something new, this is the type of organization you need to go to do that. They will be accepting. So we say, okay, let's go talk with RGW. RGW says, that sounds fine. We're happy to help you with your research. We can't put this out live on a project without it being tested. You know, they throttled us a little bit and said, let's do it in parallel. We'll do it our way. You can sit there and you do it your way, and we'll see how this does. So this is where we start from. So RGW, they give us site access, project documents, their work breakdown structure, another word for that big fancy coding system. They give us their crews, we get their production rates, their activity sequences, they give us the cost estimate, actual project production, their expert review, and of course office space on the project. So this was a very big deal for RGW. I mean, by the time we were done, the regional manager was sweating a little bit because he had just given me all of their company information they use for bidding. And so this was not easy to obtain from a company. And so SIFI, we're the partners, we provide a research assistant. We have software licenses from all our partner companies. And we have the university resources of computing and professors who we can go talk to when things don't work out. So the project we went to is the Merced State Route 99. This is a District 10 project. It was a hard bid project. And it's a $34 million, somewhere I saw it had a 33% contingency in it. I'm not sure if that was true or not, but I suppose that means they planned on this being a fairly difficult project. I heard later on they were able to pull that money back out. And we had these field trays, which is pretty typical for heavy construction projects. These are, and then some quantities, 24,000 tons of hot mix asphalt, 200 cubic meters of earth fill, 380 meter box girder bridges, 5,000 square meters of retaining wall, 5,000 meters of barrier rail, 10,000 meters of temporary barrier, and 400 meters of storm drain. Probably kind of a typical project chunk to put out for bid. And this is, I guess this is being done for the high-speed rail, which is supposed to pass underneath this bridge, and you couldn't fit double tracks. And so they're doing sister and cousin projects of this all up and down 99. On the other side of Merced, you take this project, you flip it around, and it's the exact same project on the south side of town where the tracks cross back, the freeway crosses back over the tracks. So this was a small contained project. It had some details to it, like the phasing of traffic, which made it a little bit difficult, but it wasn't necessarily, you know, like the owner of the company said, well, this isn't really something where the technology is fully tested. This was a very safe environment to go and just, you know, do a dry run with this and see how it works. So you get an idea of the project. This was just taken with a cell phone. General highway project. And this is after, this is phase 3. You can see the abutments there being excavated. And then same thing here. They have a loader, which is backfilling the footings for the vents. I thought it was interesting here that they were using a loader to backfill. You know, what's the cycle time on that? It was like 2 minutes. But for whatever reason, that morning, on that day, that was just the way that they were doing it. So when we got to the office, the first thing was, okay, let's see how they're doing things right now, so we can have a, you know, kind of a scientific comparison. So this is what we found. They have the PDF plans printed out. They had the bridge deck, topography rolled out. I think there's a cost estimate somewhere, things on the wall, highlighters, a little calculator, triangular ruler. You know, if I went back to Vitruvi in the Roman days, I might actually find these exact same items, with the exception of the calculator. You might have an abacus. I think they had paper and they drew in perspective back then. So based on the free market theory, you know, we all know this. Well, these guys are real. If this is how they do it, well, that's as good as it gets, because they wouldn't do it that way if there was a better way, because their competitor would find a better way, and they would put these guys out of business. So these guys are very sharp. And so we assume that is how it's done. Okay?
But I don't think that's really true.
It probably is, and I disagree too. I think the recent economic events.
Somebody like keyway does it very good.
Yes. But for their niche, these guys might be out of business next year, we don't know. But right now they're in business. So we went out in the field, and they have a gap. We noticed that when we left the office with all the papers and we went out to the field, there's a very different world. If I ask anyone in the field, well, what about the plants? They say, well, you know, they tell me what to do over the radio, their survey over here. There is a very definite gap between the project planning side of things and the field side of things. And so, but these are the key players, these are people actually doing the work. And I asked the carpenter foreman, he's doing his time cards, I asked him about these codes, and he's explaining these codes to me. He's getting on the radio, someone's telling him what code to use and where to put his hours. And he says, well, you think that I'm filling out all this information, that this is going into the loop where they replan what I'm going to do next week. And that even more than that, this is going to go into the plan for the next project. But he says, I've been here for 30 years, and he says, I know that's not what happens. This paper goes into a file cabinet, and nobody ever looks at it after they do the billings. And maybe they, you know, the engineer crosses his desk and he uses it for the monthly billing. So there's this gap that we found. So next is what we brought to the project. So this was our supercomputer. We built it for this project specifically, took all the most expensive components and brought them all together and tried to build a computer that was dedicated just to sim. And the last edition that allowed it to work was we added a 14-inch shock fan to it because it was we found that if we cooled the computer enough, it finally started working. So we realized we're on the edge of the technology here. Today, presumably, the computers would work better. And we have an old laptop that we run our older software on. We had a newer laptop just for screen space, and we had the big monitors here. Now we oversized the monitors because we wanted to use a grassroots approach here. We wanted to pull the contractor into what we were doing. And we wanted, as they were walking by, to go, oh, hey, you know, they see over our shoulders, what's this and what's that? So the monitors didn't need to be that big. And we did the site walk. We had a computer, we walked around the site, and we tried to bridge that gap a little bit of where we were bringing the plans out to the field. I could walk up to a superintendent and I say, hey, look at this 4D simulation. Here's my schedule. Does this make sense? And they would say, oh, no, you know, that's not that way. We've changed the plan. Or they say, oh, that's interesting. You know, we are bringing in, you know, 3 new crews next week. Or, you know, they'd say, I hadn't thought about it yet. You know, this is Monday. That's next Monday. So the model level of detail. Okay, so let's look at just the retaining wall on this project. And we'll forget everything else. So in my engineering courses, I learned that there's 3 main modes of failure for a retaining wall. You have the slope failure, you have the tip failure, and a sliding failure. And so as engineers, this is what we're taught. This is a retaining wall. It's a solid block. And we treat it as a solid block. It's cantilevered. I push on the top, and I have a lever on the bottom that prevents it from tipping. I put a key on the bottom, it keeps it from sliding. I do soil analysis, soil stabilization, it keeps it from failing. But this is how the contractor looks at the retaining wall. So when we show up with software that looks at the wall as a single object, and they look at the wall as, I don't have a count here, quite a few objects. And this pie chart is divided by cost that they had appropriated to each task, and it's ordered in sequence of work, starting with access road, supervision, place the footing, strip the footing, form the wall, place the wall, strip the wall, put the backfill, put the barrier, sandblast, finish it out, and put the stain on. It's the whole process for the wall. So with this here, of course, we don't need all of this represented in the model. Some of these can be done with assemblies. We can reuse some quantities. You know, we don't necessarily need to have a quantity for texture wall separate from the quantity for stain the wall, because the textured wall is what stains, so it's repeated. So I'm going to run through now what each one of these look like. So this is the excavate the footing and the keyway and build the rebar template. And then there's an access road. Now the access road isn't necessarily represented in the wall object, but I might want to have it represented just as an equation. When I put a wall object in there, it has an equation that represents that this percentage of the cost is for the wall. We have the tie rebar and build the construction joint. We have the place footing, strip and cure, form wall back panel and tie the rebar, form the front panel and the texture surface and the miscellaneous material. And then we have the equipment, place wall concrete, strip, cure, sandblast, and patch, and sandblast to textured surface. We have embankment fill with structural fill and backfill. And then we also have the associated costs with the purchasing the fill and hauling the fill. And then there's also the backfill drainage. We have the barrier rebar, the toe structural and non-structural fill, and staining the textured concrete. Form, place, strip, cure, sandblast, the barrier rail. And then we have the wall overhead, which is assemblies within there, you know, some contractors know that supervision for a retaining wall type activity is going to be 5% of the total cost. And I saw one contractor had broken out all these different items, not every one of them, but they had percentages that they use in their estimate to put overhead on different items. And then they had the stormwater runoff and erosion control, and an electrical conduit happened to be in this wall. So we needed a wall object in the sim that we were able to grab these quantities from, because our schedule is based on those quantities, the production rates we take from the field that the crews are turning in. We take last month's production to then forecast this month's production. So at this point, I'll turn it over to Christopher and let him go into details on the wall objects.
All right, so one day out of the blue, I get a call from Forrest, didn't know beforehand, and he's asking me if I could do a retaining wall for him in Civil 3D. So if I open up Civil 3D, it's got some walls in here, somewhere down here. Basic data retaining walls. So it's got some retaining walls in here, but none of them are really suitable for construction. I wouldn't use them as construction, and I've done it before and trying to model it, and it doesn't work very well. So Forrest definitely needed some help if he was going to pull that information for those walls out into it. And so when he called me, Autodesk had recently introduced the sub-assembly composer, and so I was pretty sure I could revise it and give him something he could use to do that. And then I asked him how much money he had for it, and he told me he had $0 for me. So I had a decision to make. Do I do it for free, or do I try to barter something with him? And so I decided to barter with him, and so I traded my services to do this for a tour of Stanford University. So I did get something out of it. I just didn't get cold hard cash. And I actually had some time back there. It was around 2009. Economy was down. Not a lot of people were calling me. And so I had some time, so I figured I'd help them out. And so I was able to break it up in sub-assembly composer. It's got pretty good tools to build the geometry using points, links, and shapes. And so I can build that wall that he needs and assign the codes to it. So over here is the basic shape of the retaining wall. And so I was able to provide him a link point. So if the roadway is up on the left-hand side, he could use it for this wide. And he could come down here and change the attachment point from right to left. I believe if I change it to the other side, it updates it, and now the tie points goes the opposite way. And he's also able to turn on and off the barrier up on top. I change that, the top of the barrier goes away for the roadway, and so he's able to customize it and actually get the thing he wants. So before sub-assembly composer, it was a really long, drawn-out process, creating your own custom sub-assemblies. You had to go in .NET and code it, and it took probably about 3 times as long to code something like this in .NET using Visual Studio than it does to use sub-assembly composer. So for this one, it probably took me about 16 hours to put everything together for this one. There was some learning time in that because Subassembly Composer at the time was new. So I could probably do this in like 12 hours now. But I was able to give him the shapes that he wants. I was able to break out this wall stem, give him specific links that he could pull out the quantities for Civil 3D from that model, from this model, instead of having to try to do it by hand like we typically do today, or some contractors do today. So I'm able to set targets, and the targets can move. And so if I turn existing surface, it'll update, and so now my daylight for the top of the wall adjusts to it. So we could either put it in as a profile or just use a target for a surface. And so he's able to build his model using the actual values shown on the plans. So here I have the top of footing profile that you could set and get the actual location where it should be based on the plans. And then you could also do the top of wall profile as well, and move it up and get it all up. And so if we look at the standard plan dimensions change based on the height of the wall. So as I adjusted the top wall higher, the bottom of my footing got smaller. And so I was able to help him process this information based on the height, so he doesn't need to think about what the height is. It'll automatically do the footing for him, which is good and bad. So it's good that I've automated the process, but it's bad because Caltrans's engineers or a consultant to Caltrans who did this really doesn't have that tools available to them, potentially. And so they've gone through and they've set their profile and their wall height, but my wall height may not actually match what he has. So it's just something that you need to look at to make sure that if you're going to model it in Subassembly Composer and set your heights, that you double check that that's what the designer actually wanted, and that they are actually using the standard plans, because sometimes the time crunch happens and we forget to go back and change that footing and width later on. And so our plans might not reflect the actual design requirements based on just the standard plan. So I created that for him, and then from that, I know how to use it. I was able then to create he was able to create a 3D model from that, and that's one of his models. So this is the daylight line as the profile goes up. So it looks like the designer could have cut some wall height off there. If they were using 3D, they've been able to recognize that and adjust it and get a little more economical design. If you look at it, one thing I don't like about Civil 3D and using corridors for design for walls is that I can't really find a good angle for this, but is that the steps aren't nice and clean, so I'm not really getting great quantities out of it. Or if I do want great quantities off it to get that nice vertical face, is that I'm spending a lot of time trying to figure it out and put those in there. Then we get down to, is it really worth that effort and time? And a lot of times it isn't. So, I mean, really, the contractor could have built it without this 3D model, which they probably did anyway. And so, that's it. I got the barrier on top, and then you can see the footing adjust and the steps and stuff. But you got a nice visual cue, a visual picture of it, and plus you're able to get the quantities from it. Yeah.
Are you using a target profile for the bottom of the wall?
Yes.
Yeah.
And then the top of the profile, then I'm taking the math, subtracting, and then getting the footing width based on the Caltrans standard plan.
Yeah.
But yeah, if you use the standard out of the box ones in Civil 3D, they don't really work very well. I'm not quite sure what world they live in, but it's not one that But there was some additional information that I probably wanted to show on the wall. But like I said, I was doing it for free. And so I actually got busy doing something other than this project. And so if I was doing it paid work, I probably would have gone in and created the extra links so you could do the quantity backfills, or the quantities for the backfill, the wall backfill, the gravel that goes there, the pipe, put in some daylights over here so it extend out from the bottom of the footing and go up 2-to-1 or 1-to-1 to the daylights. So there's a lot of improvements that I could have done to make it more, to get better accuracy. Add an option for maybe that access road that Forrest was talking about in his image. And I think that's all I have to talk about.
So without that object, the experiment was done. We would pack up and go home. There was nothing more to do because we couldn't represent the retaining walls. Maybe I could have drawn a line and just done an average massing per foot or something like that, but it was impossible to model. So these are the standards that were embodied in the wall. And so when we put it all together, these are these beautiful walls that as the walls curve along the roadway and change elevation, the footings change, the earthworks that go along with it are all put out there. And for what we were doing at this early stage in SIM, the quantities were just incredibly accurate. And so we were able to have very good numbers that we then rolled into the schedule with the quantities and with the contractor's production rates and their expected crewing and scheduling. We were able to build a schedule that was within plus or minus 3 days of what they actually did, which for scheduling, that's astronomical. But we could not have done it without this. Thanks, Chris. So we built a 4D simulation. So we do a visual check. I don't know if anyone's going to see the mistake that's in this 4D simulation. So Carl, the superintendent, wanted trees in there, so we put trees. If you look closely, there's some birds in there. Bill, the project manager, wanted to see ducks. And Teddy, the foreman, he wanted to see hawks in the tree, because he said there's hawks nesting in the tree and we're doing construction around it. So I put a hawk in there. And in retrospect, it turns out you can see the hawk over there on the right side, just at the tip of the wall where it's at there. That hawk is incredibly important, and I should have probably put that hawk with its own schedule for the nesting season. So when the hawk's nesting, the hawk appears. Same with the ducks. And when they're not there, forget them. We can build. But right now, where that wall's going in, that could be the nesting season, and we can't work. And it turns out these bridges over here, when I left the project, they still haven't started on these. These things had slid like 6 months on the schedule because there's swallows underneath them. And when there wasn't swallows underneath it, there was water over there. And they just couldn't figure out when to do that work. So I've noticed other modelers that I've seen back at the university doing some interesting stuff. And one modeled a hurricane season in Puerto Rico. And there's a professor in Netherlands, Professor Timo Hartman, who has written a paper on putting those icons in there. And so that becomes an important visual tool to see some of these softer constraints on the project that are the ones that if you violate will really mess up your project. So when we compared our model to the contractor, so when we looked at our 3D model to their 2D plan, we found that 5% of the objects in the drawings had no activities in the contractor's schedule. Some of it was simple stuff, temporary drainage, the gore in the middle of the road, but it came out to be 5% just wasn't in the schedule. They were just going to do it whatever. 33% of the activities had no objects in the 3D model, which means those are assembly items or somehow these are activities that have no object representation. Maybe like build the access road. They don't model it. And 15% of the resources that we saw were needed were not in the budget. So does that mean this project was 15% in the hole from day one? So when we went out there, we were testing this, and we wanted to test it to failure and find out, how far can we push the system. So we started off with the contractor's baseline schedule and bill of material. And everyone was like excited when we had this. We were finding busts in the quantities, and we were finding these different things, and they were real. So we validated that we can do a very good baseline schedule with this system, and everyone there agreed, this is good. And so then we assumed that the contractor's bid and the engineer's estimate and the engineer's design all could have been done with this model, because those are things that this software is actually made to do. I guess I didn't point out that we used a whole bundle of software, not just Civil 3D. But. So then we took it and we did the Contractor 6-month schedule and started updating. So we did the baseline, then we did a revision, we updated. And everyone said, hey, this works good. We're actually showing what's really happening on the project. We took phase 1 stuff and used it to forecast phase 2. And it was very accurate. But then when we tried to go to the monthly schedule and show the contractor, okay, based on the things you're changing this week, next month this is what we think we're going to see. And I remember I told Carl, the superintendent, Carl, I finished that schedule. You gave me those, when I showed you the last one, those things you said I needed to change. And he says, well, that was like 2 weeks ago. He said, oh, you're still working on that? And at that point, it was no longer useful for the contractor. And they said, look, you can stay on our project. This isn't doing anything for us anymore. But, you know, you can stay here as long as you need. We were collecting some other data. So that was the point where we found that the return on investment was no longer there. It worked good up to about the 6-month revisions, but the monthly schedule, it couldn't keep up the pace. It took too long to change everything and bring the model back up. So we continued for our own work, and we were looking at the weekly schedule because I wanted to be able to say, when I get a time card and I look at my schedule, I want that time card to match the schedule. And I shouldn't get any time cards that aren't scheduled. And if I do, there's something wrong. So we got this down to plus or minus 3 days. And at that point, there was no way of really checking it closer than that. And so then we took it a little further, and they had a major design change. They decided that the vehicle pullouts on that project were too small. There was no way to drive out of the ramp. They redesigned the retaining wall, and at that point, there was no way to rebuild the model. We had used text files. We could have just inputted the numbers, but it took so much work to redo everything that at that point, it was done. We couldn't do a major design change. And we found that that was the breaking point for the software, which I would think is fairly good. That's a fairly high bar to pass. Now, of course, if we had done what you call like a double blind, and we just handed all this and taught the engineer, go do this, and we now said, let's take 12 projects and just have some grads, you know, students, bachelors coming right out of, you know, Chico State, University of Oklahoma, and you know, Clemson, and let's just have them do us on the project. I don't know if they would still achieve the same level. Maybe they would get better. But this is what we found. So how long did this all take? We were there for 2 years doing this. And we have recorded 2,000 hours of work. So this is my, my invoice, my time sheet. And so we have a breakdown here. Spent quite a bit of time learning on this. You know, we estimated that if we had done this 6 times, we would reduce the, through learning, we could probably pull this 2,000 hours down to about 300 hours. We could punch one of these out. And with some modifications of software, maybe get it down to 150 hours. So then you get a couple people on it, you're talking about a week's worth of work. But we don't, that's just an estimate. But what we did, this was the time. And so we have preparation, learning, hardware setup, spent quite a bit of time on hardware. The integration, a little bit of time on planning our CAD. Maybe if we spend a little more time on that and less time on some of the other things, we would have done a little better. The base surface, the alignment was pretty quick. Doing our profiles, our sections, and this is about where Christopher came in, and we needed help there. Then build our corridors, surfaces, solid objects for the bridges and the abutments, the vents, and all the custom, massings. We built locations into the model, which means we took what usually is a model that would have one location, and this one here is corridors. We split the corridors into 28 corridors, and then we multiplied that by 3 corridors wide, just because of the way the software is set up. So we ended up with something like 90 corridors, which then started to, we had to go back to hardware again. So the coding system, we had to build that in. There wasn't a lot of provision in all the software for the coding, so we had to build that into everything and just reuse some fields. Quantity takeoffs took quite a bit of time. We had to validate this. Spent a lot of time between the contractor's estimate, Caltrans engineers' takeoff, and ours, and figure out, okay, why don't these numbers match, and where is the mistake? Scheduling, 4D visualization, documenting all this. We have a website. We documented all our notes called Civil VDC Wiki. If you Google it or search it, it'll just come up, and it's raw notes in there, but it's all documented. It's openly available. And then site walk. that's where I got to actually use this. And that's the amount of time I spent, you know, just walking around and talking to everyone and showing them what I did. So you can see that the amount of time we actually used the system was very small compared to the amount of time we did in setup. And so because we were there in the office the whole time, I'd show up at 7 a.m. when the guys opened up the door, they let me in, and I was there till 4 o'clock at night. If they let me stay, I was there till midnight. And they were able to watch all 2,000 of these hours the entire time. And believe me, they felt that was much too long. But that's what it was. So some challenges. First, we weren't able to validate that this VDC closes the gap, and we were able to cross the gap with the field with our handheld devices. You know, in a perfect world, the contractor would have bought us all iPads to give out to the superintendents. Superintendents would have been looking at our model, updating it, doing their time cards with the model. But after 2,000 hours, they were not interested in that, and I don't, you know, there was no point in going any further. But this is, I think, you know, I think everyone here agrees, this is definitely the future of bringing the model out into the field. Closing the loop right now, showing the guys in the field what we're going to do. You know, when I showed them that 4D model, I remember the guys in the field saying, wow, I didn't know we were building that retaining wall way over there. You know, we've done a quarter mile of it, we thought we were done. But no, it's almost a mile-long retaining wall. But the feedback loop of how do we represent what's actually happened out in the field and get it back into the model, we haven't found a solution for that. That's 100%. It would have been nice to have gone that far, but the technology and where we are today just didn't support that last step. But we got the feed-forward loop and a little bit of the feedback. So for future work, the biggest, to me, the biggest stumbling block to me was that core spine of that representation. So that I know that this item in the schedule is this item in the model, which is this item in the cost estimate, which is this item that I'm looking at out in the field. And I need a way of representing those and matching them one-to-one. But just by nature, those items aren't at the same level of detail. They have to be elaborated. The schedule is abstracted from the 3D model, and the estimate is way more detailed than the 3D model. So I need a way to elaborate across levels of detail, and there's no easy way to do that. I haven't picked up any paper that explains to me a theory of how to do that. And there's lots of practices out there, and I can figure it out on my own, but if I try to teach somebody else that, I might as well teach them how to do art and paint a picture. So if somebody could figure that out and create a standard that all the software vendors use, how do you elaborate across a level of detail? And then, of course, putting that standard into library objects so that the objects are able to elaborate themselves. So I can have the retaining wall object for my engineering analysis, I can have it for my abstract bid estimate, and I can use that object all the way down to the contractor's project monitoring. So to recap, we talked about virtual design and construction at the edge, which I guess is the, you know, the perimeter of the organization where the rubber meets the road. And we talked about partnering and embedding with the field operations. And we elaborated the VDC sim model to the field level. And we see that there's some key challenges that still remain. And so with that, thank you for your time. And I'll be happy to talk with you guys about what you think. Yeah.
I think the most important thing you discussed today was this concept of embedding, which coincidentally is what we were discussing last night over a reasonable quantity of beer. A lot of us in this room. So what I've seen, you know, I'm a practitioner, but through the TRB, I guess what I've seen, you know, what they're calling research in CHRP is somebody gets some research, and then somebody gets it, and they do a document search of academic papers that were obsolete by the time they were written. Half of the stuff they're citing is their own past work, and they put together a questionnaire which they send out, which everybody lies on, including myself, and they produce a report which isn't even close to reality. And so we're just like what you're talking about, embedment. Basically, you get to see the back killing, you get to see. You know, it's like
I got to drink the tequila.
You know, you didn't. It's like, you know, Jane Goodall did not send a questionnaire to the chefs, right? So I think, you know, what you're talking about as embedment is actually more important than the information that you presented today. What's important is how it's collected, which I think is far better science and far better research than document searches and questionnaires.
Yes, I agree. I can't take credit for any of that. Kevin's not here from PB, but Kevin worked with Timo Hartman on the project. It was a PB underground subway project in New York City. I'm not sure what it's called, but that is where Timo developed this idea of embedment, and that you have to go out and you have to go to the field. And I saw he just did a proposal for a 3-year ethnography. You know, this 2-year ethnography is too short. So of course it's very expensive. I mean, who's going to pay my salary and support my family for 3 years while I'm out there?
I thought grad students were on minimum wage.
Less than that.
Just some information, kind of FYI. I'm Mark Down. I'm with Caltrans, and I was watching what Chris did. I think Chris is now teaching some classes for us, one of the vendors. Is that right, Chris?
Yeah, I'm teaching hydrology and hydraulics.
Have you taught our structures class yet?
I'm just teaching hydrology and hydraulics.
Oh, that's it. That we go in and we do a retaining wall in Civil 3D, you know, and it's you know, we end up with stuff looking like what you did. Of course, our frac, we could have used your thing for free a few years ago, but it wasn't available.
It was on my blog.
You started in 2009. You know, we did that in 2011. We couldn't quite rely, or we just didn't go the route of the what's it called, the model object.
Yeah.
And so it was done using like C# or something like that, .NET that way.
Definitely.
And then those tables changed. I'm sure that you're aware of that, right? For the side, you know, the depth of the wall and stuff like that. And so, but anyhow, we've got a class that kind of details from a design point of view that process of building the wall.
Yeah.
You know, using the step profile of the bottom of the wall and the top of the wall profile and stuff like that.
You guys are still in the early stages of learning how to use the software.
If you get a chance, take a look at the manual that we put together for
Okay.
the structures.
My next class, I'll be in Fresno next week, so take a look at it.
The other thing, we're just implementing Civil 3D now. We were using Casey software up until that time. We have a lot of those retaining walls available there, but who does that retaining wall work can vary depending on complexity of that, which I'm not quite sure of. We do the design engineers that do the roadway design. Over certain limits, that goes to our structures group. The class that we're talking about was made for the structures group, you know, and hitherto now, you know, they hadn't really been using that type of tool. I mean, they were more interested in the SAP and that type of thing. And one of the things about the modes of failure of the retaining wall that we didn't talk about is what you learn in the concrete design class. You know, where does the steel go? How much do you need? What's the moment at the bottom? That type of stuff. And so they're focusing on those types of things as well. And a lot of that in your time graph for what the guy is doing to build the wall has got to do with that type of detail. But just for what it's worth, we're kind of adapting. We're slow sometimes, but we're getting there.
There's a lot of tricks out there. You know, it's like there's, you know, you do Civil 3D and there's tricks on how to model it in Geopack and Inroads and Actec and TerraModel, but you know, underneath all the fundamentals are the same. It's just, you know, it's just using a different tool. And I think you know what I'm seeing here. Even if you didn't understand everything you saw, that's a pretty accurate picture of a real life project. You know, at the $30 million range. So it's a $300 million project. You may have seen different systems and technology. It's a $1 billion project. You may have seen more sophisticated. But I would, you know, from what I've seen, the observations you were reporting were a fairly accurate picture.
I'm Jeff from Caltrans, and I do CAD support, microstation-wise, but I also write the CAD standards. So my question to you is, did you kind of think about or guesstimate what you do with the as-built situation? So once your model was done, you know, and the contractor's done, we got to get as-builts. So because I have to work with legal and write those standards for as-builts, and they're in a DGN file. So taking a model, coming back into basically a 2D GG file for legal reasons. Okay, not because we're engineers and we like 3D or 4D or 5D, but from a legal perspective, what was your considerations of as-built, and how do you think that would have worked? I know you didn't get that far, but just your thoughts.
That's a really good question. So as-built, I mean, obviously this is not what was built. This is what Caltrans handed off. You know, I dropped it in Google Earth. It has Christopher's retaining walls here. The black speck up there, that's the gore. And then it has a large fill here in between the ramp and the roadway. So I went out and took pictures of what they did after they built it. You know, I was looking and I said, hey, you guys filled that up. It was almost humped of dirt in there. And they said, well, it said, you know, this slope or better. So we filled it up. I don't know why they did, but they did. So that would be an as-built, is the as-built should show that that gore is filled to the brim with dirt, front to back. So that would be a good case study of how would you as-built that. I mean, like the laser scanning presentations we saw yesterday, I think would be an excellent way to do the as-built. Of course, you know, the schedule and isn't as important in the quantities, but as you're saying, the geometric 3D.
Yeah. But again, as a contractor, you're handing this off to the contractor, and I guess one of the issues, if it's not a design build, if it's a regular design bid build, is now it comes back to either the consultant designed it or Caltrans that designed it. And so the design squad that now really does the as-built, you know, getting the markups from construction. So passing the information around to some other people, if it's not just a contractor, and the contractor made modifications and volumes to, you know, alignment, heights of walls, whatever, you know, we're doing, or lengths of dike or anything, how does that get captured back around? Because right now it's paper, for legal reasons, but it just trying to look into the future, how best to use a model to do that and get back into the system that it will have to go to tort liability.
I have an idea. Okay, so here's the best one. Is about 2 weeks ago, some Stanford seniors, you know, they went through the undergrad program, approach us and say, we'd like to use an unmanned aerial vehicle for construction. We just like vehicles. What can we use it for? I think that would be a perfect example. Is if you overflew the site, say every day, and took a laser scan. And you're using like some quadcopter or something of these things. It's going to fly itself, it thinks, you know, it brings you your soda out the side, I don't know. And so, but if that flew, and what our interest is, and where they became interested, we were able to say, well, you know, we have an accurate model, so you would know where to fly your quadcopter. Otherwise, you're just going to have to fly a grid over the whole thing and just collect what you can. We can tell you, you know, for this day, you want to fly specifically here, and look for these things to scan. Now, on a heavy construction project, I think something like that would be able to access most of the site and get a real, including the underground utilities, when the trench is open. You know, it still leaves open the scenario where they open the trench, put the utilities in and close it all at once. But from my perspective, it seems the 3D imaging.
Right, which handles one part of it, which is the geometrics, the super of the road, because you get sued because the super's not steep enough. People go off in the desert and we get sued. Yeah. All right, but what it doesn't cover is structurally the footing under the ground. You know, and when a designer now comes back, because basically there's two users of the as-bills. Yeah. One is legal for tort liability, and that's the geometrics. And well, why didn't you have the barrier higher, or you know, whatever your rule. The other one is the designer starting the project 20 years from now. Well, how deep was the footing? Right now, our structures uses rebar, you know, to calculate rebar and how much goes in there. So if I have to modify that footing, I have to come in and say, well, what do you have currently? That you're not going to get that from flying over, from point clouds. So
well, you do the point clouds as you do your construction. So you go out there and after they set the rebar, you go out there and scan.
You know, but you also have it drawn up and quantified, because that's what they're going to get. And again, who's going to pay for that cost of modeling all of this after the fact? Because sure as shooting, whether you're in construction or whether you're the contractor, when you're done with that job, you're moving on to the next one. They don't even want to do as-bills because, well, that doesn't really pay me. I'm moving on to the next job. It's very difficult to get good as-bills.
But it has been done on some design build projects, not by the contractor, by the the professional engineer in charge of the construction quality assurance as part of it, because, the contractor's in charge of quality control, but in most states, professional engineer is in charge of the construction quality assurance and acceptance. Well, you gotta collect objective evidence to do that. So on some design builds, provided the consultant's smart enough to negotiate tight scope and lump sum fee, it's like, why you do all this paper? We just collect X, Y, Z. So you outfit people with maybe one survey grade with mostly high accuracy mapping grades, and you turn the inspectors become data collectors and everything as it's happening. So instead of writing some narrative report that goes in the fire safe, it's just data collection all the time. And that was the objective evidence that things were constructed according to plans and specifications. And it was brought in, you can overlay them to bring the microstation files and ArcGIS and overlay it, or we take the 3D stuff, compare it to the inroads template to see, get 1,000 points, and it was very rich data, and allowed a construction quality assurance staff to basically do the same thing with like a third of the normal staff, which there's the profit incentive. What we came up against, it was a design build in Utah about 4 or 5 years ago. Is at the end of the job, when the design builder handed over to Utah DOT, we showed them this. We took them the room. We showed them everything. It was like millions of pieces of data and hundreds of thousands of records. And like, well, this is cool, but we need the forms. We need the paper from the warehouse. And so we just kind of programmed it. Sent all the data back to forms and back to through the microstation, through the sheets. Hit the button and let a laser print all weekend, and gave them a whole pallet of paper. So they got the paper, and went to the warehouse. But what Utah DOT didn't get was which was 100 times as much information, was this rich, huge electronic data set that we collected over years that proves that the professional engineer in charge of the construction quality assurance did their job. So the technology's there, and the technology actually made money, but the roadblock was, I call it the psychology of legacy organization, which is not, that's something that technology can't solve, and not even engineering can solve it, but it's like we've met the enemy, and he is us. We've got all these things we can do, but our brains choose not to do it. And how we change organizations, whether it's DOTs or transit agencies or airports or even design builders, is a problem whose solution is bigger than me. But it
so
is.
you're saying you can do what he wants.
I have done it.
Okay. Well, I think that's what he was.
We did it, and we did it to make money, because I know it sounds cold. We did it to eliminate jobs instead of. This is a huge, half a $250 million design build job. Instead of having, the normal 15 people we require for construction quality assurance staff, we did it with 5. But what we used, we used the technology we needed to basically turn them into biological data collectors. It was just stuff coming in all the time.
This is I-15 then?
It was close to, it was a different design build up there. It was Pioneer Crossing.
So you're saying it can be done, it has been done.
And has been presented at ASCE, and I presented it at the TC, I guess the FHWA conference they had in Orlando a couple years back. And so but it's not, the technology's there. It was like off the shelf. We were using, handheld things with Trimble TerraSync and stuff. The design was microstation with inroads, and sometimes we used the survey grades. We used whatever technology was necessary, but the power was in the data model, the information system, how we thought about it. But when we got to it, it was, and the design build contractor we were working under loved it too. But when it got to the owning agency that had to accept it in the end, it wasn't ready for that kind of data sophistication.
Okay. Well, excluding design build now, let's just talk design bid build, that this job was, he ran into a problem, with the design change. So we have mandatory design exceptions, and you got to get them signed off by whoever, and then it gets implemented. How do they get back into the model during construction? Your optimum time was, getting the stuff out to them, which you want that initial thing, but when you get really granular, are they really going to take the time and want to take the time on a design bid build job to come back and keep updating the model, to give you, a schedule change? And how do you capture all of those? And that's legal's concern, is they want every little change. If you extend type C dike under the guardrail 20 feet, they want that. Well, construction goes, that's not important. It's not important. So it's what you capture and why you're capturing it for legal reasons. And when they go to tort liability, they don't care about the engineering. They're going to say it met our highway design manual book. The cross slope of the road, the super of the road. They don't care about how many points you have. They care about that it met the design standard at the time. We won't get sued. We have design immunity.
So the bigger question would be, what is legal willing to pay?
That's one of them. And right now it's 2D paper, and they want a clean set of what was the condition when the contractor left.
But what is that worth to them? What is the risk that Caltrans is at in the context of not having that data to a level of quality and volume that they sleep well at?
Yeah, and that's a struggle right now.
But I think you both hit on it because the old legacy design build paradigm is just, it's this three-party adversarial relationship. Everybody wants to limit what they do, to limit their responsibility and liability, until you really get to like an integrated project delivery type thing, which design build certainly facilitates. You're not going to have that that cooperation to get all the data from the design phase into the construction phase, back to legal, back to asset management, facilities management. It's just it's not in any one party's interest to do that.
Well, I mean, what he's talking about is part of why we're forming this new ASCE committee. To basically, we're not going to talk about technology, we're going to talk about practice.
Right.
What you're talking about is not a technology issue, it's a practice issue and a business case issue of what happens when all of our practices go from analog to digital, and what are the legal implications, and how to, it's like, suppose we want to do something, but the lawyers don't like it. And so, what you're talking about is very real. Yeah.
But you started with what, microstation drawing files? Is that your?
Yeah, we're really not okay. That was what we started with.
Right. So.
Yeah, that's what I was gonna ask. You got nothing electronic, like when you took that photo, what was it, a house anyhow, or wasn't a trailer that they had that information in?
It is a house.
Is a house?
They bought a house in Merced. It was cheaper than the trailer.
Right, and it had no air conditioning, a house in Merced?
It had air conditioning, and I was in the kitchen.
That fan,
I think contractors do that. One contractor bought a house, they had like a jacuzzi and a Jen Air grill.
Yeah.
But what did you got?
Summertime it was nice. It was really cold in there. Yeah, the computer was running really good. But in the wintertime they would heat it, and that was the problem.
But what did you get in terms of electronic plans from Caltrans? Like nothing?
They just handed me. Val was the engineer. He handed me. It was a file full of DGNs.
Okay.
And they were sheet DGNs. And I said.
And you got nothing from
They weren't even the master files.
Yeah, was there a master file of the whole model, and then from that they do the sheet DGNs?
Yeah.
So they chopped it into sheets. They brought it forward into sheets and chopped it all up.
Yeah, I got the sheets, and Val said, no, there's no model anymore.
Well, there's a model somewhere.
One of the other things I would say is, like, in between the time that's happened, there's been another thing where Jeff knows more about this than I do, but we have new policies on electronic sharing of data. So now before bid may be a different story, but at least after bid, if you want, at that time it would have been our Casey files, okay, or maybe you could get those into some other format, like maybe you could use a land XML type of thing to do whatever it is that you use, Civil 3D or whatever it is, that you can bring things over a little bit easier instead of having to hand build that model again by yourself.
As it turned out, I really didn't need the files. If you guys had just sent me like an Excel spreadsheet with all the with the profiles, the survey data, it's really easy to feed it into the software. So I spent most of my time just with PDFs going station to station and creating Excel files with all the top and bottom of the wall, the cross slope percentages, and then I was just feeding those into the computer. I didn't need to see the interface really. If I could have, I just would have. And there's the model.
Yeah.
There was very little handwork in here. I think
Okay.
the 3D masses was in the bridge objects was the only thing I did by hand.
Everything else was just data files.
And you guys, I'm not sure what the punchline is to this, but this is so pertinent and very interesting. I'm looking at an email that I just got yesterday from a design liaison on a project in Wisconsin that we did some clash detection on. And the email I got from him is basically saying there's a design issue that came up, and they had to remove part of anchor slab in a retaining wall that was conflicting with the curb. And so we did clash detection with curb and retaining wall, and the question drawn back to me is, or the statement here, so the construction head here, Ryan Luck, wanted to know if we could have caught this as part of our 3D clash detection. He said it could be a lesson learned item. Could you please add a recipe to make sure that we do not have overlap between roadway, curb and gutter, and structure anchor slabs? So, on the one hand, it's really helpful feedback, and it's really helpful to know that the construction team is aware of the tools and is sending it back and saying, well, okay, this is something that potentially could be caught. Can we look into this and try to figure out? So maybe the punchline is, for it to be aware forms what you were mentioning before as a really helpful feedback loop. And so now we can actually go back to design and make sure that we have this recipe and look for it. There's probably other punchlines as well, but I think this is
Well, the as-built fits into that perfectly, because if you've changed something for the as-built,
Mhm.
well, that clearly, there was a reason for it,
Right.
and that feeds back into design. And with this here, you can get it's very easy to
But,
see.
but you said that it'd be very hard for you to go back and remodel it or take too much time. You made the illustration that you were a little bit late getting it to them and they had already moved on, or whatever the decision was, or timing, or anything else. So at the end, when you're making changes, is the model as useful for the benefit of the contractor, not for an end product, where you go flat and you do all that, but to help you finish out and do the punch list, so to speak, of a job. How helpful is it compared to upfront, which I think it has much more benefit, in giving it to the contractor, and so on, in a bid, in a normal
build.
design build job.
For as-builts, I think that's a great point. I think it's incredibly useful. If I did this for a living, and I was a modeler, when I started on this, Dana Prober at Autodesk was teaching me how to build a corridor by email. I didn't know the first thing about the software. I just opened it up, and it was what we needed. We tried a few different softwares even, we probably went through 3 or 4 softwares for every aspect of this, and I had to learn each one and try. So if I knew the software, I'm pretty sure I could have done this much quicker. Over the course of 2 years, I got better at it. But the design change I couldn't include was they replaced the entire retaining wall on the east side of the freeway with a whole new wall. And so that was going to be a major overhaul. My daughter was being born in a couple of weeks, and my wife was actually said, "No, you're done." So I could have tried. I probably would have bought another computer. It worked a little faster. Gotten a year newer computer and tried to add that change in there. But of course, we're all under deadlines. I had to get home, and when it came down to it, I couldn't make the change. But I think if this was their job, it would, like if Christopher was there, if they had hired Christopher and he was the guy, let's say we had a good research budget, I hired Christopher and said, hey, for a year, go there and run this experiment. Now, it would have been that would have been a different story, because all that learning curve would have been gone. And then I think a lot of things would have been a little different.
There's a lot of contractors that they collect a lot of data on this stuff, if nothing else to prove to themselves that they constructed according to plans and specifications. And I'm not a lawyer, from my perspective, there is no legal reason why I guess that we call it contractor quality control data, not for sampling and testing, but for workmanship and as-built, could not be used as part of the legal acceptance done by the professional engineer, as long as it's statistically validated. I've talked to the people up in DC. I mean, it actually is in line with the philosophy behind 23 CFR 637B, right, of using contractor produced data that's statistically validated, that the professional engineer says, I certify that this is constructed according to plans and specification. That becomes the electronic as-built. So we have, we've got the technology to do it. we've got the legal freedom to do it. It's just we don't have the civil engineering practice methods to do it. We got to define those. The civil engineering profession, we've got to define what is good practice in a digital world, and I don't think we're there yet.
Well, I mean, currently you mentioned about on these drawings or the 3D model, someone needs to keep updating it. At some point it's going to be a snapshot unless whatever is being built is what is being represented.
Well, but you do that in design. That's like basically if a file's revised,
Yeah.
the old file is gone. You put a new file in.
Well,
Matter of
sure,
fact, if you say what changed, that's where you grab the tools. The
Well,
DG
that's it.
compare and say, oh, here. And so it's just like you don't have to. It's like the old days of voiding out sheets. Who cares? Just here's a new file. Boom. This
That's
is the file
design build though.
Yeah, and that's currently and it's currently used just as a tool, for building, but it's not like the final deliverable that's used as as-built, is my understanding. Is that correct?
Because legal's comparison is to the as-awarded files,
Yeah.
the day the contractor starts, that's
Right.
legal. Okay, that's not you and me.
Plus all the revisions, right?
Well, that's addendums prior to,
Okay.
but the day he starts. And then the as-bills incorporate all the CCOs. All right, that's what they compare. All right, they don't care what happened in the middle. Don't care what happened in the middle. Don't care why you really did it, as long as you can back it up from an engineering perspective and a standards perspective.
Well, this is good. I mean, these are the practice issues we want to discuss in ASCE. I call it the technology agnostic issues. These are, I mean, it's a good thing you brought this up because these are real things we got to address. Whether it's California or Texas or whether it's transit or airport, these are, the nuances change from place to place. I realize that, I guess, the traffic liability in California is particularly harsh, kind of a litigious environment until it changes from state to state. But the fundamentals of it are the same whether you're in California or Florida or New York. So this is good stuff.
I have one comment. Something you mentioned at some point that you would like to see a model that provides a mapping between quantities and a 3D model. Did I interpret that?
We did have
correctly?
we have that in there.
Yeah, as a comment, but you would like to see that as a further development, as a standard that evolves from this work, right?
Yes, that's true. We had to hack this together,
Sure.
and there was no process embedded in there for us to even know to try to do that. We just had to know the theory and know this has to be done, and then figure out a way to get the software to do it. An example on moving those quantities and those items across miles, I had to write some code in C++ to take the information out of Civil 3D, no, it was VICO, to go from the line of balance, like Primavera, okay, to go from the schedule to Navisworks, because we were using incompatible softwares. We had to write a piece of middleware that would take the time and activities and put it into a format that we could put into the next software. I think that's a little tangential to what you're specifically asking, but the software, if you just give me a box of software, it won't necessarily work together. There's certain softwares that will work together, but there's definitely no platform that says all softwares will work together.
Yeah.
There we go. Okay, now I'm in the room.
Yeah, like trying to get microstation files as the background and Trimble terracing.
So the quantities to go from the representation of what that quantity represents, I also want that to go from software to software.
And the quantities provide a more disaggregated view than the 3D model.
Yes.
Which
exactly.
means that the 3D representation of anything should be done at that level and then aggregated in a way that you can establish categories, and the modeling and the standards should enable that.
Yes.
And I think you highlighted that's a clear need. And that also has to deal with data exchange between different platforms.
Yes.
Right, to ensure that that information is inherited and exchanged and it is not compromised.
So I assume somebody here is with the Building Smart. Anyone?
No,
You're talking about Building Smart Alliance with
Yes.
ZIPs?
Yeah.
No, but
But
interesting that you should mention that because in January, at the annual TRB meeting,
That's right.
we are having a joint workshop between NIBS and TRB on that Saturday. Because, like I said, Cuddy and I had to ruffle a few feathers in TRB because TRB didn't want to do it, but Deke Smith and Nibs kind of pushed for it. And it's a whole day-long workshop. We've got contractors, we've got people coming in from the UK, and the people, go to the Saturday workshop. Hopefully we get a fill of room. If it goes poorly, my name is Mud. But yes, it's like totally. We're only doing it because Nibs is having their conference in the Marriott up there the week before the TRB. So it's like we get these vertical and horizontal people in the same room and see what happens.
So this would be a perfect example to put on my wish list. This would be my contribution to my wish list. Is I would like the new IFC Building Smart IFC standard. Was it industry foundation classes?
Yeah.
They're making a civil version. I think it's Francis Gogling at Illinois is head of the committee. I haven't met him, I just got a name, and I think he's U.S. Army research or something like that. I'd like them, when they sit down and go over the standard and they're developing it, to have, now I don't know how, of course this would be like a proposal, but to do the research and take the time to learn a method of doing elaboration through the model, and being able to, exactly as I said, be able to associate those different items across, because even the IFC in the building set isn't really set up.
Yeah, and I think it's all based on the concept that if you divide the project into objects and then assemble the whole thing and then keep that at the lowest segregation level. Because if you do the 3D model at a higher aggregation level, you try to go the other way around, and it's pretty tough.
Yeah.
And so I see exactly what you're saying.
Well, because we tend to focus on the technology and standards and not the practice. ASCE, the Structural Engineering Institute, has a BIM committee. All they talk about is gadgets. And the Architectural Engineering Institute has a BIM committee. All they talk about is the gadgets. And ASCE's got a computing thing. All they talk about is Cray computers. Even Dick Smith told me, building smart lines, they're all just fixated on gadgets. But because to step back and talk about practice is tough. But over in the UK, that's what the Institution of Civil Engineers is doing. They're 10 years ahead of us because they're stepping back and they're looking at the theory of practice in this new digital world and trying not to get distracted by the gadgets.
So to add on to that, the one thing you have to add that's missing here, and we talk about quantities, in Caltrans, who drives quantities, who drives the bid items? It's the spec engineer that doesn't even touch a computer, doesn't even do 1D.
Yeah.
Okay? But their legal language that they write in the standard specs and in the NSSPs that are written, that takes precedent over any graphic. You can draw whatever you want, pretty picture with anything, and the spec controls if there is a dispute out in the field.
Is the spec, is that talking about like what's a structural fill and what's non-structural
Well, yeah,
fill?
determine,
Those
well,
details.
at 50 degrees, you can't do this, place AC, all the spec language, you can show a utility line, but to say that I have to call a guy 24 hours before, that's all in the specs.
Yeah.
So that's all
Right.
specs, and more, our practice is to remove the specs out of any standard plans, anything, and put it in the standard specs. How it's bid, how it's, so that is the driver of how the pay is. So they have to be involved, at least with Caltrans, has to be involved, let alone with the designers, because a lot of times what happens, the designers will design this great thing and then throw it over the thing to the spec engineer and say, well, don't change anything.
Yeah.
Well, then spec goes blah, blah, because they have to sign and stamp the specs.
That's what I call it, plans, specifications, and estimates.
That's right. It's all together, so specs has to be a part of this if you want also quantities, in the discussion of quantities.
That's where this started. And we glossed over that part.
Right.
But
No, I'm sure, yeah.
we had a slide of the drywall in the office in their house.
Right.
Where the field engineer, the project manager, and superintendent basically gave me a lecture for a day. They pulled out the spec book and they started explaining, look, your model's fine, but this doesn't mean anything because we have to know we have the spec.
Yes.
And your model needs to, maybe we should have, I guess we didn't really highlight that in there. We're trying to adapt, mold to the spec, and
Right.
Well, that's another issue with the civil engineering profession. We've got, we have this passive voice. Basically, we write narrative style requirements, right? That's what our profession is, like a story. And as we go digital, part of our discussion is maybe we should start moving to, the the DOD style, the system engineering style of requirements management. Basically, the DOD, when they do a stealth fighter, basically they don't write a narrative. They put all these requirements in this mega relational database, and once they agree on the requirements, the relational database becomes the specification set. It's a different way of looking at it. And so, to move into this digital thing, maybe we as civil engineers have to start learning what systems engineers do in the aerospace and how DOD does their requirements management. It's a totally different world. But I don't think that our traditional civil engineering narrative approach to specifications will work in a digital world.
No, it's good. I saw, we get early work with this way back when we first were proposing this. It got selected to be shown to the Lockheed Martin executive team at some luncheon, and they needed, poster sessions for them to walk around and view. And they joked, they saw this and they saw it from the system side. They said, "Oh, we need a shuttle information model," which brought me up to the point because you guys don't have a shuttle information model. So
that's language from COSI, the systems engineers. Ironically, that 800-page systems engineering handbook, most of their examples are civil engineering projects from Europe.
I have a question. This session is about return on investment.
yes.
And I may have missed it, but what was the overall economic benefit of doing what you did?
Well, since we had, as we know, that as the, we put nearly no money into this, and the benefit, of course, was something. And so as you divide something by something that approaches zero, the ratio, of course, goes to infinity. So we get an infinite return on investment.
Well, I guess the return is you get a dissertation, right?
Yes. So the real return.
Yeah, but just the contractor's acceptance of what you were doing. I mean, you made great inroads in here on doing that. But from that, because I don't know if you can quantify it. I don't think you can. But what do you see the return to the contractor in your opinion?
Did you save the money, or did you?
Okay, so because it was an experiment, we tried to use the contractor as a control. So in all reality, I didn't want to affect their behavior, trying to do science. So many times we didn't tell them things we saw that were really screwed up. Most of them were in the schedule. In another presentation, we have really good representation of where in our schedule, with our quantities using their productions from the previous phase of the project, not their bid production rates, we could clearly see that their false work construction progress with the crew that they were using was going slower than the bottom deck for the bottom of the bridge. That sits on the false work. And we could see clearly that even though they started the false work, maybe like a month after the bottom deck after the false work, they understood, they knew that the false work would take longer, and they started it earlier. But we could see that at the midpoint, they were going to get run over. And I saw it, and I waited patiently. I needed to get the photograph so I could present and show. I wish I had the graphic, but we'll let it be. So I stood out there for, my accuracy on the schedule is 3 days. I actually stood out there for a couple days, and I just waited. And sure enough, one day, there's the guys with the false work on the ground, and they're building it. It's David and Jorge, and I forget the other guy. And up above them, they call them beam walkers, are the guys doing the bottom deck. And the guys on the bottom deck are basically kind of looking down at the false work guys. The false work guys are kind of looking at the bottom deck guys. And they've gotten run over at that point. And so I could have told them that would have been a return on investment.
There you go.
Long before, you guys either need to increase your false work guys, or you guys need to, which they couldn't because they had constrained workspace, they need to either cut their bottom deck guy crew in half, they had 2 crews running, or maybe they do that for safety, or they need to just have them go home for a while and do something else.
But there was no exercise, even informally, to try to identify, okay, this, or at least this would have been the economic benefit of X, Y, or Z.
Yeah, we can't put a value on it. They'd be pretty wide. It would be a guess. Yeah.
And only if they were conducive. Just because you observe something wrong doesn't mean they'll accept.
Yeah.
You pointed it out.
No, nobody will accept that false work. I've shown that to other people, and they go, "Oh, these guys are screwed up. Or these guys didn't know what they were doing." A real contractor would have done that the correct way, but I'm like, I think these guys are as real as they get. It was real.